Good evening, students.
Good
Am I
evening.
audible?
Yes.
Good evening,
Good
sir.
after Good evening, sir.
Good evening. So let's start the class. So in the last class, we started the arc heating. As we have discussed, the arc heating is used only in case of furnaces, not for general use or household application, as the arc is inherently unstable process, and to stabilize the arc, we need a different kind of arrangement. Okay, so generally we use reactors for stabilizing the arc. And why the arc is unstable, that also we discussed in the last class. Okay, uh, so let's start the class. Now, as we have seen, the arc is unstable. So that means the characteristics that we get for the arc, as we have discussed in the last class, suppose there is any perturbation in the current, then the resistance decreases due to that current because it ionizes more area, and this decrease in area induces more current. So that means it's a uh, positive feedback process, and therefore it's the unstable process. Now, if we want to represent that characteristics of R, like VI characteristics, so then we would get this type of characteristics. Generally, we plot V and I like this. In our electrical, we generally prefer to plot the V in the y-axis and current in the x-axis. Unlike the electronic curves like diodes and other nonlinear devices where the current is along the y-axis and voltage is along the x-axis. Okay, so this is the common plot for VI curve. Now, if I want to plot the characteristics of R, then we would get this type of characteristics for R. Okay, and therefore we can call it a negative resistance characteristics. So this R gives the negative resistance characteristics. Okay, here. So that means if there is any change, so the resistance decreases. Okay, but in case of normal resistance, you know, if there is any change in current, then the voltage increases. Okay, so this is the voltage drop which increases by increase in current. Now here, if the current is changed, the voltage decreases. Just the opposite. So therefore, it's a negative resistance characteristics. Now, how we can stabilize this? Okay, so we can stabilize this by using a reactor in series with the arc. Now, reactor generally gives a positive characteristics like this. Suppose this is the characteristics for reactor. This is a positive VI characteristics, as I know. Now, if we add these two because they are in series, suppose this is the arc, this is the arc, and you have connected a reactor in series with that. Okay, so the net characteristics that you will obtain by uh, adding these two characteristics. So if we add these two characteristics, so what should we get? We get this type of characteristics where at some point it will reach the minimum. So this you can say the resultant characteristics. Okay, and these characteristics which we get by adding these two, as we have connected these two in series. Now the right half portion, if I take this point as O, the right hand portion, if you can observe, the right hand portion gives you the positive resistance characteristics. Again, the left half, again you are getting the negative resistance characteristics. So that means if I want to have a stabilized process, then we should operate the furnace. That means we should keep our operating point at the right half of this O point. Okay, and how that will be decided? That will be decided by the value of the reactor, the reactance value of the reactor. Okay, so that means by proper selection, proper designing of the reactor, we can stabilize the arc. For an example, as we have mentioned in the last class, that very common application of this arc is there in fluorescent lamp. Now you have seen that for fluorescent lamp, we use some ballast. What kind of ballast we use? Now the conventional type of ballast is basically the reactor type ballast, which is heavy. Okay, so unlike the electronic ballast, the inductive type of ballast or reactive type of ballast are generally heavy. Okay, now if we go for other type of lamps like HID lamps, that also I discussed in the last class, but that you will study in the other part of the subject. So HID lamps, if you see this type of lamps like mercury vapor lamp or sodium vapor lamp, SON, SOX, etc., there you will find the reactor is used with these HID lamps are quite heavy, maybe 3-4 times heavier than the ballast which is used for the fluorescent lamp. Now, why so? Because the current rating for the fluorescent lamp is quite less compared to the HID lamp. Okay, so that means to get a stabilized point, stabilized operating point, the design is such that the reactance value of the stabilizing reactor for HID lamps is quite high. So therefore, we need heavier reactor for HID lamps. Okay, so that means the operating point selection decides the value of the reactor. Now you can assume that what will be the size of the reactor which will be used for the arc furnace, because for arc furnace the rating is in the order of kiloampere. Okay, maybe 3 to 4 kiloampere, 3000 to 4000 ampere. Now you can assume that what will be the size of that reactor. Anyway, so this is the advantage. So this is the purpose of using stabilizing reactor with arc furnace. So this is one of the reasons for which we use stabilizing reactor for arc furnaces. Now another purpose of using this stabilizing reactor is to prevent the short circuit at the beginning, at the starting. Now, as we have discussed in the last class, that you also have some exposure with the arc in your arc welding classes. that to initiate the arc, first we have to touch the electrode with the plate, isn't it? So that means a direct short circuit. Because to start with, we have to do that. So here also for arc furnace also you have to do that. So at the beginning, first we have the electrode should be charged with the charge. So that is the called the short circuit. Now in the short circuit, there will be huge current flowing through the transformer. To prevent that short circuit, to limit the short circuit current, the reactor is used. So another purpose of using the reactor is to prevent the or limit the huge short circuit current at the beginning. Okay, is it clear? So these are the two purposes of reactor for arc furnace. Any question?
স্যার ওই ইনিশিয়ালি
Any question so far?
কারেন্টটা কেন হাই হয় আর একবার বলবেন?
Initially, that is a direct short circuit, na? So as we have seen in the last class, that to start the arc, first the electrode should be touched with this. Then we have to make a distance between the charge and the electrode. So this is if this is the electrode, and if this is the charge. So at the beginning there is no arc. What you have to do, you have to make contact with the charge. So that is called the, so suppose this is R and that is coming from a transformer. That is R. So huge short circuit current will flow. To limit this short circuit, we need a reactor in series.
ওকে স্যার।
Got the point?
ইয়েস স্যার।
Okay. Now, as I have just mentioned, that for arc furnace, the current rating is quite high. That is in the order of kiloampere. Now, why so? Why this current rating is in the order of kiloampere? We can also keep the voltage high because you know that power loss can be defined either V square by R or I square R. So that means high power can be achieved either by keeping the voltage high or by keeping the current high. Now, why we are taking the I as a variable? Why not V? So that is the question. Okay. The first point is high. If we keep the voltage high, voltage means the voltage between the electrode and the charge. So if we keep the voltage very high, because to get the high power, we need voltage to be high. If the voltage is high, then what will happen? The distance between the electrode and the charge, there we have the air. Now the nitrogen present in that air will be ionized. Why? Because of the high voltage gradient between the electrode and the charge. Okay, so due to this high dVdx, the nitrogen present in the air will be ionized. And if the nitrogen is ionized, then what will happen? This nitrogen, ionized nitrogen, will be absorbed by the metal. Okay, and it will create the nitride of the metal. And this process is called the nitriding effect. Nitriding effect. So that means at the surface of the metal, the metal nitride will be formed. And these nitrides are basically a brittle material. Okay, so that means the high voltage is basically results in the embrittlement of the metal. Generally, therefore, we don't prefer high voltages for arc furnace. So that is one reason. Another reason is if the voltage is kept high, then to maintain the arc, the gap between the charge and the electrode, that is the distance between the charge and the electrode, will also be high to maintain the same amount of current. Now that means the length of the arc becomes more. If the length of the arc is more, then what happens? The radiation from this arc is more, and therefore the roof and other parts of the furnace becomes heated unnecessarily, because your objective is to heat the charge only, not the roof or other part of the furnace. Now if continuously you make that those parts heated, what will happen? The life of those parts will decrease. Okay, clear? So therefore, we try to keep the distance between the electrode and the charge small, so that the life of the roof and other parts of the furnace can be increased. So that is the second point. Clear? So therefore, we
Yes.
prefer high current rather than high voltage for arc furnace. You have any question?
No, sir.
Okay. So here we can write small arc length for less voltage. Now there are two types of arc furnaces. So before that, I should say a few words on the advantages of arc furnace. So generally, electric arc furnace is referred as EAF. EAF. Okay. Now, why this electric arc furnace is preferred? What is the advantage of electric arc furnace? Now, point one, that it can produce the EAF. The EAF can produce steel with high purity. And exacting analysis. Okay. Number 2, the EAF can operate 100% steel spare feedstock, which is called cold ferrous feed. Okay. Number 3, the capital cost to uh, install an EAF is only third of that of an open hearth furnace. Okay. Now, open hearth furnace is basically the conventional furnace. Now, these are the advantages of electric arc furnace over the conventional furnace. Now, there are two types of arc furnace. Depending on the operation, one is called the direct arc furnace, another is the indirect arc furnace. Similar to your direct resistance heating and indirect resistance heating. Okay, so depending on supply also, arc furnace can be divided into two, rather three. So DC and AC, and under AC you have single phase and three phase. Generally, the DC arc furnace and three phase AC arc furnace are more popular. Okay, now direct arc furnace, here the charge itself carry the current, just like we have seen for the direct resistance heating. So if we see the direct arc furnace, if this is the supply, here if we have the charge like this is the metal. Here the arc is formed like this, and a part of the circuit is the charge itself. So here also the current will flow. That means the current will be heated by the arc as well as the ohmic heating, because the charge itself carries the current. So here we get an inherent starting process. So that I will discuss later. And the indirect resistance heating, you have the electrode less arc is formed between the electrodes only, and you have the metal like this. So metal gets heated by the radiation. Here the metal doesn't carry the current. So that is the difference between the indirect and direct arc furnace. Is it clear? So these are the electrodes. Okay, and here you have the supply. Any doubt so far?
No, sir.
Okay. Now let me start the direct arc furnace. I'll share a picture on that. Then we'll discuss that. Can you see this?
Yes, sir.
Yes, sir.
Okay. Now this is the schematic diagram, not the exact one. This is the schematic diagram of a three-phase AC direct arc furnace. How we can understand that this is a three-phase arc furnace? As we can see, there are three electrodes. Okay. Now the arc furnace, the direct arc furnace, generally made up of three parts, major parts. The topmost portion is called the roof, and the bottommost portion is called the hearth, Hearth, and the middle portion is called the shell. Clear? So that means the roof, shell, and hearth. So these are the three parts of the furnace. Now, roofs are generally water cooled to increase the life of that roof. Now, the total body is made up of a very thick steel plates, but the lining of the hearth is made up of a special type of material. It can be either magnetic, uh, ma- magnesite bricks or silica bricks. Bricks means the int, and that what type of bricks we should use, that depends on the nature of the charge, whether it is acidic or basic. Okay, and that is called the refractory lining. Here also a point is there, that is called the refractory heart. So the inner portion of the heart is made up of refractory lining, the material of which can be either magnesite bricks or silica bricks, depending on the nature of the charge. Okay. Now the steel nails are there that you can see, and the slag. Slag means the you know what is slag?
Sir, impurities. Three impurities.
Correct. The impurity present uh, in that mixture. Okay, so this process, the purpose of the process is that only. So we need a pure uh, iron or pure metal, and we have to remove the impurities. So impurities or slags are removed from the slag doors shown in the figure. The other side, you have the vertical tap hole to collect the pure metal in molten form. Okay. Now the electrodes are attached with the electrode mast. That means the roof along the electrodes generally lift it up to maintain the distance between the or maintain the length of the arc. So therefore, that I will discuss later. So that means the electrode masks are there to hold the electrodes. Okay, so one more thing is there at the bottom that you can see in this figure, that hydraulic rocker cylinder. When the melting process is going on, you have to rock the furnace. You have to stir the molten metal. This stirring basically accelerates the dislagging process, isn't it? Are you getting? বুঝতে পারছো আমি কি বলছি? এই যে আমি যদি when the melting process is going on, if I start the metal properly, then the dislagging process মানে dislagging মানে হচ্ছে impurity যে বেরিয়ে যাচ্ছে, পিওর আর ইম্পিউরিটি যে বেরিয়ে যাচ্ছে, ইম্পিউরিটি গুলো উপর দিকে ফ্লোট করে। এই যে প্রসেসটা যত আমি এটাকে স্টার্ট করতে পারবো, যত আমি নাড়াবো, তত আমার ডিসলাইকিং প্রসেসটা অ্যাক্সেলারেটেড হবে, ইজন্ট ইট?
Yes, sir.
তাই তো নাকি?
Yes.
ওকে, সো তত আমার রিফাইনিং প্রসেসটা ফাস্টার হবে। ওকে, বাট this this type of furnace has some inherent stirring action. Why? Because here the charge itself carries the current. মানে এর একটা ইনহারেন্ট স্টারিং ব্যাপার আছে, কেননা চার্জটা নিজেই কারেন্ট ক্যারি করছে। স্টিল উই নিড সাম স্টারিং অ্যাকশন, এক্সটার্নাল স্টারিং অ্যাকশন। ফর দ্যাট what we do, we keep a coil just below the heart, and through the coil we pass a very low frequency current which aids the stirring process by induction. আমরা কি করি, এই যে হার্টের তলায় একটা কয়েল রাখা, and through that coil আমরা একটা লো ফ্রিকোয়েন্সি কারেন্ট পাস করাই। সেটা কি করে, এই যে মোল্টেন মেটাল, বেসিক্যালি সেটা মেটাল, সেখানে ইন্ডাকশন করে। ইন্ডাকশন মানে বেসিক্যালি এডি ইন্ডাকশন, এডি ইএমএফ ইন্ডাকশন। সেই এডি ইএমএফটা কি করে, এডি কারেন্ট ফ্লো করায়, and due to that eddy current, there we get the stirring action, and that basically aids the stirring process, that helps the stirring process. Got it? মানে এখানে আমরা ডিফারেন্ট স্টারিং অপশনস আছে। ওকে, তাহলে বোঝা গেল দিস schematic. Now just a minute. Now we'll see that what are the different types of material we used for electrodes. Okay, so before that I want to show you some video for actual process of arc furnace. এটা না দেখলে ঠিক okay, so let me open that first. So it will give you some sort of exposure that how it look like and how the operations are going on. Just a minute. দেখতে পাচ্ছ? I haven't shared that, না?
না স্যার, এখনো দেখা যাচ্ছে না। এখন আসলো, ওটা পরে চলে গেল।
দেখা যাচ্ছে না তো?
না স্যার, এখন দেখা গেল।
The melting not yet started. It will start. You can see the mast and the cable connected with the mast and electrodes also. So loops are getting open, loop is getting open, electrodes also kept at the highest position. Roof is closed now. Electrodes are getting lowered by the mast. Electrode গুলো নামানো হচ্ছে, দেখো। Okay, so just now it has started. You just observe the cable. So the cable you can think of it is a 6 inch or more than that thick, the diameter of the cables. Now you can imagine the weight of the cables, but those cables also just dancing when the arc is started. Just observe. Okay, দেখতে পেলে?
স্যার দেখতে পারলাম।
Can you tell me that why the cables are dancing like that? দেখছিলে কেবল গুলো কেবল গুলো কিন্তু এমন নরমাল কেবল নয়, কেবল গুলো ভীষণ মোটা মোটা কেবল, মানে এক একটার যেটা বললাম আমি 6 ইঞ্চি বা তারও 10 ইঞ্চি মোটা একটা কেবল। অত মোটা কেবল মানে ভীষণ ওয়েট তার, সেরকম মানে কেবল বলতে সেগুলো তোমার 3000 অ্যাম্পিয়ার ক্যারি করছে বা মোর দেন দ্যাট। ইন দ্য in the starting it is more than that. Why the cables are dancing like? Can you explain?
স্যার এই চার্জের জন্য হতে পারে, ওই চার্জ ডেভেলপ করে
দেখলে? হ্যাঁ বলো এবার। চার্জ বলতে চার্জ তো আছে ফার্নেসের মধ্যে, কেবলস আর আউটসাইড। Now, I think in the first year or maybe some other classes, you have studied that if there are parallel conductors and current flows through them, then what happens?
ফোর্স অফ অ্যাট্রাকশন আর রিপালশন।
Force of attraction or repulsion depending on the
Direction of current.
sign of the direction of the current, okay, phase of the current, okay, isn't it? Now সেটা জাস্ট আমরা মানে পড়েইছি আর শুনেছি আর কি ফোর্স, কিন্তু আমরা দেখিনি কোথাও এরকম যে ফোর্স হচ্ছে দুটো কারেন্টের মধ্যে অ্যাট্রাকশন হচ্ছে। Now here the current amplitude is quite high, in the order of kiloamperes. So therefore the force of attraction and repulsion are quite high, which is sufficient to move these heavy cables even. Yeah.
Yes.
Yes. Okay. Now, what are the different types of electrode materials? Now, different types of electrode materials which we use for arc furnace. Number one is very common is the carbon electrodes. Number two, graphite electrodes. And number three, Soderberg electrode. So these three electrodes are used for arc furnaces. Now, what is the different characteristics of electrodes? Okay, so there are two types of characteristics. One is called the electrical, another is the mechanical. So electrical characteristics such as the you can say high conductivity. Okay, uh, what are the other characteristics? Electrically আর কি হওয়া উচিত? Okay, the conductivity is high. So what are the mechanical? Mechanical characteristics are much is more important than electrical characteristics in this case, because mechanically they should have sufficient mechanical strength. There should be resistance of thermal shock, because huge thermal shock the electrodes have to face. Okay, and some chemical characteristics also they should have, like the insolubility, chemical inertness, etc., etc. Okay, so these are the characteristics of electrodes. Now, as far as the characteristics are concerned, if I if I take the electrical characteristics only, that is the conductivity. So between the carbon and graphite, which is better?
Graphite.
Do you have any idea?
The graphite.
Okay, because what is the resistivity of graphite? The resistivity of the graphite is quite less compared to the carbon. Okay, it is only 1/4 of the carbon. So therefore, for the application of carbon electrodes are limited for small furnaces. For larger furnaces, we prefer the graphite electrodes for their high current carrying capability. Okay. Now, another type of electrodes I have mentioned here, that is the solar electrode. Now, what is Soderberg electrodes? Now, Soderberg electrodes is made up of special type of paste. Okay, তোমরা দেখেছো কিভাবে ব্রেড করে দেখেছো? How the breads are made in bakeries? Have you seen? Okay. প্রথমে first we make a paste kind of thing out of the flour, isn't it? Right? Then what we do, we heat that paste, and after some time it is baked and becomes hard. So here also in Soderberg electrode, it is basically made up of special type of paste, and there is a container for the electrodes, and we add the paste from the top. Okay, suppose this portion is the container, and this is the electrode. We add the paste from the top, and suppose here the arc is, so this is the metal, and this is the container. Now this paste in the heat of the furnace, the paste becomes baked and forms the electrode. Now what is the advantage of that? Now when the process is going on, when the arc furnace is on under operation, what happens, যদিও আমরা সমস্ত রকম ক্যারেক্টারিস্টিক্স দেখেই নিয়েছি লেখাকে, বাট there will be some erosion electrode. ইলেকট্রোডটা ক্ষয়িতে থাকবে, মানে ক্ষয় হবে. Then what will happen, the length of the arc is changed, becomes more. But to ensure an efficient operation, the length should be adjusted properly. The arc length should be adjusted properly. So this is suppose the length of the arc. So that should be maintained. Now what we have to do, we have to lower the electrode to maintain the length of the arc. Ever, if it is a fixed length electrode, so after a certain time you cannot lower further. There will be some mechanical limitation, isn't it? But in case of Soderberg electrode, the electrodes are basically continuous type of electrode. মানে ইলেকট্রোডের লেন্থটা তুমি মেনটেন করতে পারছো by increasing the, or by adding the paste from the top, and thereby increasing the electrodes, isn't it? Are you getting?
Yes, sir.
Yes, sir.
বুঝতে পারছো আমি কি বলছি? This is a special type of paste. Okay, এখানে আমরা এই লেন্থটাকে মেইনটেইন করতে পারছি. So therefore the Soderberg electrode is called continuous type of electrode. Okay, so these are the different types of electrode material. Now come to the power supply required for the arc furnace. So as we have mentioned that for arc furnaces, electric arc furnace or EAF, we need very small voltage, very low voltage. The voltage is less than 100 volt. Okay, but the current is very, very high. Now that is maintained by a step down transformer, but the rating of the transformer is quite high, and the transformers are generally dedicated transformers. So for one arc furnace, we should have a single transformer dedicated, and the output current rating will be in the order of kiloampere. So that means we need a transformer, dedicated transformer for electric arc furnace EAF. One more thing we required. Can you tell me what? inside transformers, what we need? What else we
Ballast.
need? We don't call it ballast. Generally, the ballast term is used for the lights. We call it stabilizing reactor.
मुझे बता रहा है टीचर भी हरामी है ना भाई जो आम जो है ना तो बोला ना कि लोग से डरे क्या है ये
Okay, so generally we call it stabilizing reactor. Okay. Now, if I take the equivalent circuit of the transformer or the secondary equivalent circuit of the transformer, the reactor and the resistance of the arc into consideration. So then we can simplify the circuit by this. So we have some resistance, some reactance, and the arc resistance, which is the process resistance here. And here we have the voltage input. Now, what is the R1 here? What are the different components of R1 in this equivalent circuit? If I know the configuration, we have step down transformer, then we have reactor, then we have the resistance or the arc furnace. If that is the configuration, then what are the different components of R1? What is there in this R1? Can anybody estimate that?
স্যার কোশ্চেনটা
What
স্যার
are the
একটু প্লিজ
different
রিপিট করবেন স্যার
parts of R1? I'm asking that the plant I have explained. So we have step down transformer, then we have stabilizing reactor in series with the secondary, and then we have the arc furnace. So this is the process, or this is the plant. Now for the plant, we are drawing an equivalent circuit, which consists of two resistances. One R1 is the equivalent resistance, RA is the arc resistance, and X1 is the equivalent reactance. So what is there in R1? এই R1 এর মধ্যে তাহলে কি কি রেজিস্ট্যান্স আছে? কার রেজিস্ট্যান্স আছে?
ট্রান্সফরমার রেজিস্ট্যান্স স্টেবিলাইজিং রেজিস্ট্যান্স
স্টেবিলাইজিং তো রিঅ্যাক্টর। বুঝতে পারবে? আচ্ছা, ট্রান্সফরমারের রেজিস্ট্যান্স বলতে কোন রেজিস্ট্যান্স? If you know the transformer equivalent circuit,
কপার লস রেজিস্ট্যান্স
copper loss resistance কখনোই আমরা সিরিজে লাগাই না। You should know that. Copper loss resistance are connected in parallel, and for approximate equivalent circuit, for most approximate equivalent circuit, generally we neglect the shunt branch. So that means the copper loss component of resistance and magnetizing reactance we neglect in most of the cases. At least for
ট্রান্সফরমার
power
ওয়্যার
system.
রেজিস্ট্যান্স
Okay, so R1, the first component of R1 is the total referred resistance to the secondary of the transformer. Referred means here we have both the secondary copper resistance and the referred primary copper resistance. মানে R2 plus R1 prime, যেটাকে আমরা বলে থাকি। Okay, so that means we can write here the total referred resistance of the transformer. এটা একটা component. What else is there? So what is there in the circuit? You just think of. which contribute the resistance, which can contribute the resistance.
Inductor resistance.
The electrode as a resistance. Electrode as a resistance.
So the resistance of electrode, correct? Now the reactor, the resistance of the reactor is quite less compared to these resistances, isn't it? Because reactors are made up of definitely some finite resistance, finite length of wire, but that resistance we can neglect. So resistance of the electrodes and some lead resistances. Lead means contact. Okay, so leads resistance. So these are the different component of resistance R1. Now in X1, what we have? Similarly, we can say that what is there in the X1. X1 এর মধ্যে কি কি component থাকবে? বলো। Here also we can write the total referred leakage reactance, isn't it? We call it leakage reactance. Total referred leakage reactance of the transformer to the secondary. Now, what else is there in X1? Another major component.
The stabilizing reactor reactant.
Okay. So the reactance of the stabilizing reactor and some lead reactance. Okay. Now, if that is the case, then if we want to determine the power, because here the main plant is the arc, so we always need the maximum power should be dissipated through the arc only. So that should be our objective, isn't it? In this process, because arc is the point of interest here, so we determine a condition which will give us the maximum power condition through the arc, that means through the RA, isn't it? So that means how we can determine that condition which will give us the maximum power condition for RA. কি করে পাবো বলো? When the RA will dissipate the maximum power condition for RA. How we can determine that? Can you use the maximum power transfer theorem for that? Or something else? বলো? Any idea?
x1 টাকে মিনিমাইজ করব, কারণ x1 টাই তো একমাত্র ভ্যারিয়েবল, মানে কন্ট্রোলের মধ্যে।
না না, সে ঠিক আছে, সেটা তো আমি দেখবো সেটা পরে যে কোনটাকে মিনিমাইজ করা যাবে না যাবে, কিন্তু আমার এখানে কন্ডিশনটা আমি কি করে বার করব?
root over r1 square plus x1.
r1 square plus x1 square.
Hmm.
So that means you what is that? That is equals to what?
স্যার আর এ মানে আর এর ভ্যালুটা ওটা হলে আর এর অ্যাক্রস এ পাওয়ার ডিস্ট্রিবিউশন ম্যাক্স।
So you were saying that r1 square plus x1 square. How we can say that?
তাহলে দুটোর মড ভ্যালু সেম হবে, তো তাহলে আর এক মানে আর এর অ্যাক্রসে ভি ভি স্কোয়ার বাই 4 আর এ ওই মানে 4z এ বা আর এ ওই পাওয়ারটা ডিস্ট্রিবিউট হবে যেটা ম্যাক্সিমাম। এমনি যদি x1 না থাকতো
Are you
তাহলে
saying this from maximum power transfer theorem or
yes sir, maximum power transfer।
কিন্তু maximum power transfer theorem তো সেটা বলে না। maximum power transfer theorem কি সেটা বলে? বলো। কে বলবে? কে বলতে চাইছো বলো? সংগ্রাম কাঞ্জিলাল। This is the thing from your circuit theory. Sangram Kanjilal, are you there in the class? You just logged in and Sangram Kanjilal, okay, he is not there. Okay. Rajkumar.
Yes, sir.
Can you tell me this?
No, sir.
You don't know the maximum power transfer theorem?
I just forgot, sir. I'm not remembering.
Okay. Parvez Musharraf. Sheikh Parvez Musharraf. Okay. That means so many students are not there. Virtually they are there, but actually they are not in front of the device. Shaikh Rahman. Shaikh Rahman
Yes, sir.
is also not there. Are you there? রেসপন্ড করছো না কেন?
এটা ঠিক কাজ করছিল না।
Can you tell me this?
স্যার forgot it.
Maximum power transfer theorem মনে নেই? Why you are studying electrical engineering? That wonders me. You should not continue electrical engineering. You just leave it. Ali Hamjan.
Yes, sir.
Can you tell me this? Maximum
Sir,
power transfer
that
theorem, can you recall?
yes, sir. The external resistance should be equal to the magnitude of the internal means resistance plus reactance.
No, that we don't get from maximum power transfer theorem. Who can tell me this? Anyone out of this 28 participants? কে বলবে?
Sir, here load impedance is equal to the complete source impedance.
Load impedance equals to, শুনলাম না তোমার কথাটা, শুনতে পাইনি আমি। বলবে কিছু? Anyone from lateral candidates? Shreyas Khatri? Shreyas?
Yes, sir.
বলতে পারবে তুমি?
স্যার এটাই হবে। আমি মানে বেসিক্যালি দ্য থিওরাম যেটা স্টেট করে যেটা এক্সটার্নাল ওই রেজিস্ট্যান্সটা হয় দ্যাট ইজ ইকুয়াল টু রুট অফ দ্য ইন্টারনাল রেজিস্ট্যান্স প্লাস দ্য রুট অফ দ্য কি বলেন দ্য রুট অফ দ্য ইন্টারনাল ইম্পিডেন্স মাইনাস মানে কি বলে বেসিক্যালি ম্যাগনিটিউড স্কোয়ার রুট হয় বেসিক্যালি
No. No. It's not the related to the magnitude square. Actually, there are two versions of maximum power transfer theorem. One is applicable for DC,
Sure.
and you know for DC we don't have any reactance, so we can say that the load resistance will be equals to the internal resistance. So that is applicable for DC because in DC we don't have the impedance concept. But for AC, as far as the maximum power transfer theorem is concerned, so we should have the impedance both in the load as well as in the internal part. And in brief, we can write the ZL should be the ZI conjugate. So that is applicable for AC, which means that we should have load resistance which will be equal to the internal or source resistance, and the reactance, load reactance should be opposite to the internal reactance. So these are versions of maximum power transfer theorem. None of this is saying this one, because here this is the special case where we have a resistance in the load, but there are two parts, that means both the real and imaginary part in the internal impedance, internal part of the circuit. Opposite also can happen. You have only resistance in the internal part and you have both the real and imaginary part in the load. So in that case, again, you have to go for this simple differentiation of the power expression, and ultimately you will get this. So this is right, but you should know the maximum power transfer theorem properly. Anyone want to point out anything? কেউ কিছু বলতে চাইছিলে?
স্যার স্যার এই কমপ্লেক্স কনজুগেটের এক্সপ্রেশনটাও তো ডিফারেন্সিয়েট করে পাওয়ার ম্যাক্সিমাইজ করেই এসেছে।
হ্যাঁ অবশ্যই, নট অনলি দ্যাট, all this also and this also.
তাহলে স্যার ওটাকেই কেন
But
ম্যাক্সিমাম
see
পাওয়ার
all this,
থিওরেম বলছি?
but the statement of maximum power transfer theorem is that only. Like whatever the statement is there, you cannot change that, na? Statement is statement. So you can add one more part to that, but generally this part is not mentioned in maximum power transfer theorem. Can you show me any literature where this special case is mentioned with the maximum power transfer theorem? Okay, so that means you see, not necessarily for if you take this one, here also the impedance of the mod value of z will be matched, but that may not give you the maximum power transfer condition, because here we need the complex conjugate. মানে উল্টোটা কিন্তু ট্রু নয়, মানে যখন আমার দুটোতে ইম্পিডেন্স আছে তখন জাস্ট মড ভ্যালু দুটো ইকুয়াল হলো আমরা ম্যাক্সিমাম পাওয়ার ট্রান্সফার হচ্ছে এটা বলতে পারি না। So we should match this condition. We should fulfill this condition where the resistance value is exactly equal and the reactance value will be opposite.
We can say that here, due to resonance condition, we will get the maximum power transfer, and unity power factor will give the maximum power.
It is not the resonance condition also.
So XL equals to
Is it a
XI
resonance
star.
condition?
XL equals to XI star, then the impedance will cancel each other on only the resistance.
Okay, so what this maximum power transfer theorem you are saying?
Yes, sir.
Okay, so that in a different term we can say, but none of this theorem, maximum power transfer theorem for DC and AC, is giving you this formula directly, isn't it? So that I want to point out here, but that is very important one. So if we have only resistive part in the load and you have both resistive and reactive part in the source side on a internal circuit, so then we have to conclude like this. Okay, but you should know the theorems. So that is the basic requirement of electrical engineering. If you don't know the Thevenin's theorem, superposition theorem, maximum power transfer theorem, Norton's theorem, okay, even then you can also forget this Kirchhoff's current law, voltage law, even Ohm's law. Okay, and we face this type of answers in our general variables at the final year. So this is very unfortunate. How a student can forget Kirchhoff's current law and voltage law and all these theorems, and will be graduate. Yes, he will be graduated from Jadavpur University. So anyway, ঠিক আছে, আজকে আমি আর কন্টিনিউ করছি না, কেননা actually I don't know why you are not attending at your full strength. Ankit, what is the reason for this?
Sir, I don't know.
Every day I am getting only
Today I
50% or less than that. And
today I asked everyone to attend, and prior to the class also I gave them the intimation to attend the class.
I will report this definitely to our HOD and ask her to take a drastic step against this. Maybe in form of a step that will be reflected in assessment. এটা চলতে পারে না। Every day I am getting this. Like the last class also I mentioned, you are not taking the thing seriously. We are taking the classes seriously every week at a particular time as per the schedule, but you are not taking the thing seriously. যখন যার মনে হচ্ছে ক্লাস করছো, অন করে রাখছো, অন করে ঘুরে বেড়াচ্ছো, লগ ইন করে ঘুরে বেড়াচ্ছো। কেউ অর্ধেক জনের ক্লাস আসছেই না। And group of students, I am just observing for last many classes that a group of students are not attending the classes. সেই গ্রুপটাকে আইডেন্টিফাই করতে হবে ফার্স্ট। তাদের সমস্ত রকমের মানে রেকমেন্ডেশন হোক যাই হোক তাদেরকে বন্ধ করে দিতে হবে। Because third year is not the end of your career. Okay, but I have to thank whoever is attending the class and whoever seriously uh, attending the class every day. Most of the lateral candidates I am getting every day. Follow.
স্যার ওই পাওয়ার ইলেকট্রনিক্স ল্যাবের ব্যাপারে কথা ছিল। স্যার ওই আরসি তে তো সিরিজে স্যার অ্যানালিসিস করতে পারছি না, মানে ট্রানজিয়েন্ট দিয়ে করছি তো তখন ভোল্টেজ অ্যাক্রস ক্যাপাসিটরটা পেয়ে যাচ্ছে, কিন্তু ভি নটটা তো ভোল্টেজ অ্যাক্রস ক্যাপাসিটর প্লাস রেজিস্ট্যান্স ইন সিরিজ হবে, আর ওর পরে মানে অত ট্রানজিয়েন্ট অ্যানালিসিস দিয়ে করার পরে কারেন্টটাও বার করতে হচ্ছে, তো এটা by derivative we have to find out the current, so it is becoming very much complex and স্যার হচ্ছে না পুরোটা। স্যার প্যারালালে করলে হয়ে যাবে।
ওকে, সো যতটা হচ্ছে ইউ জাস্ট মানে যতটা হচ্ছে সেটুকানি রিপোর্ট করো। ইফ we need discussion, we can arrange one more class on that, on your laboratory class. আমরা আলাদা করে একটা এক্সট্রা ক্লাস অ্যারেঞ্জ করতে পারি। তোমরা আপাতত যে প্রবলেমটা দেওয়া আছে, টেকিং দ্য আরসি ইন সিরিজ টু প্রসিড, যতটা হচ্ছে ততটাই করো।
ঠিক আছে স্যার,
যতদূর ডিরেক্ট করতে পেরেছো ততটা করে ছেড়ে দাও।
ওকে স্যার। স্যার ট্রানজিয়েন্টটা ইয়ে একটা বেসিক ইকুয়েশনটা যেটা থাকে সি ই টু দ্য পাওয়ার মাইনাস টি বাই টাও প্লাস স্টেডি স্টেটটা ওইটা দিয়ে করেছে, মানে পুরো ডিফারেন্সিয়াল ইকুয়েশন দিয়ে করেছে।